Okay, so I'm going to try to do this quick. Okay, so I did number one. I'll do number two. So they say use the graph of the function to write the definite integral as a limit. Okay, so if you're going to write a definite integral, we'll kind of do practice with that too. Okay, whoops. Okay, so the definite integral, you'll write kind of where the area goes from and to, and those will be the limits. So 1 to 4. The function just goes on the inside. And then just have that dx there. Okay, and then this will be limit always as n approaches infinity. Number of subintervals just goes to infinity. This will always be the sum from k equals 1 to n. It's adding up all the intervals from 1 to n. There's n subintervals. And then all you're doing is, here I'll kind of do this. So like up here, you've got this like delta x, and this is if you're doing RRAM with these, and unless it's a strange one, they'll always use RRAM. The only difference between RRAM and and LRAM is the k minus 1 instead of k. But here, so we'll do this. So this will be a plus b minus a times k over n. Okay, so wherever you see an x, you'll put this. And so basically you just rewrite this function here, but instead of that x inside the square root, you'll put this. And for us, a is 1, so b minus, and b is 4, so b minus a is 3. So our expression is really 1 plus 3k over n, and that's what we're plugging in for x. And maybe I shouldn't write delta x. I should just write x. I should just write x. It's really xk. That's kind of a mistake by me. That makes it confusing. Maybe. Let me do this. Not delta x. This is really xk. That's better. Okay. And then we'll plug that in for all the x's. So we'll write just the function. So I'll kind of do this 2, and then square root, instead of x, we'll do 1 plus 3k over n, and then finish off the plus 1. And then on the outside, that's really what the delta x is. I don't know why I did that. I think I did that in class. That's a mistake. Okay, that's the b minus a over n is delta x. And then for us, b minus a over n is 3 over n. And then that's what goes on the outside. Okay. Okay, so we'll get more practice when we do it with these. So write the area of a region. Write the area of each region bounded by the graph of each function and the x-axis as a limit expression of the Riemann sum. Okay, so we're doing the exact same thing, we just aren't given a graph. Okay, so let's do that first. Let's get the xk and the delta x. Okay, so the x sub k. Okay, so it's a, which is 1, plus b minus a, which is 4, times k over n. And then our delta x is b minus a over n, so 4 over n. Okay, this is what we'll plug in for that x, and then this is just going to go on the outside. So it'll be 2 times, instead of x, right, 1 plus 4k over n plus 1, and then the b minus a over n goes on the outside. And that's it. Okay, next one. Okay, a is 0, so it's 0 plus, but we don't need to write that. And then b minus a is 2 minus 0, so 2k over m. And here, I'll write that up here. So delta x, a plus b minus a times k over m. Okay, and then, oh, that's xk. Why do I keep doing that? It's so weird. Sorry. Doesn't matter too much, but. Okay, delta x, that's, okay, so that's the b minus a over n, which is just 2 over n. Okay, so now our integral from 0 to 2 of this function dx is limit approaches infinity. Okay, and then we'll write our function, but instead of the x, we'll write 2k over n, and then put the b minus a over n on the outside. Okay, next one. So xk is a plus b minus a times k over n. So a is 0 again, so b minus a is 1, so this is really just k over n. And then our delta x is just 1 over n, b minus a over n. Okay, so our integral from 0 to 1, same exact thing as limit as n approaches infinity. N of, instead of x, we'll write k over n to the 4th, and then our b minus a over n goes on the outside. Okay, last one. So a plus b minus a over n, that's just 2k over n, and our delta x is b minus a over n. Integral from 0 to 2. Okay. So 6 minus, instead of x, we'll write 2k over n squared, and then the b minus a over n goes on the outside. Okay, and just to see what each of these things are, this here, you're plugging in an x value into the function, and so this will be the height in the kth subinterval. This is the height of the rectangle, and this is the width, and so you're doing just height times width, so this gives you the area of the rectangle in the kth subinterval. And then when you let k be 1, and then 2, and then 3, all the way to n, this adds up the area and all in rectangles, and then this lets n go to infinity to get the exact area. So we know when the number of subintervals goes to infinity, that's when the area of this limit approaches the real area and then equals the real area with the way limits work. Okay, so that's that first page. Okay, next one they say write the area represented by the limit as a definite integral. So this will be that little integral symbol, the s, you know. So we got to figure out really just have to figure out a, b, and then the function, because that's all that goes in there, you know. So when you're doing, when you're writing it, it's going to be always a limit from a to b of some function dx. The only things you really need are the limits, a and b, and the function. So remember, there's technically an infinite number of ways you can write this. So I'll write it kind of I'll assume that this number that's added inside, if there's a number that's kind of added inside, I'll assume that's A. And if there's no number added, I'll assume A is 0. Okay, so I think the first place to start is figure out what A is. So A is 0. And then look at what B minus A is. So the thing on the outside that's divided by n in each of these problems, the thing that's divided by n on the numerator, that's B minus A. So in this case, B minus A is 3, since it's 3 over m. And that means that B is 3. So we found like 2 out of the 3 things just from that. So we know that this is the integral from 0 to 3. And then now, just like in the previous ones where you substituted that little delta x, a plus b minus a over k, or b minus a times k over n, you substitute that for x. Now you'll go the other way. Wherever you see a plus, this here is a plus b minus a times k over n, and replace that with an x. And then so that's just x to the 4th. And then put a dx. Okay, and then they ask you to evaluate that with a calculator. So if you're using your graphing calculator, just do math 9. Math 8 is derivative, math 9 is integral, and then just type that in. Okay, so I'm going to skip that. They're just getting you practice knowing just where math 9 is, and yeah. Okay, so next one. So start out with A. So there's nothing, you've got like kind of paying attention to this thing that looks like it's inside of a function. So or really anything that has a k in it, that's actually the best thing. Anytime you see a k, you're going to get an x in the function. So here we look at this 3k plus n. There's nothing added, so we'll say a is 0. Okay, we got this 3 over n, which is almost the same. If that's a 3, that's usually a 3. These are usually the same numbers, but really look at the thing on the outside. That's the more, that actually could be different also. But okay, so b minus a is 3, and that means that b is 3. Same as last one. Okay, so we got our integral from 0 to 3. Okay, and then this is our little a plus b minus a times k over n. That gets replaced with an x. So this is just e to the x dx. And that's it. Okay, next one again, there's nothing added. So a equals 0. We're really paying attention to this thing with k. Nothing added. And then b minus a is really pi over 2. B minus a is pi over 2. If you divide this by n, if you divide pi over 2 by n, you get pi over 2n. So really b minus a is pi over 2, which means b is pi over 2. So integral from 0 to pi over 2. Okay, and then this thing with k, this is that's b minus a times k over n. So that is just gets replaced with an x. And that's it. Okay, next one, we'll say a is 2, the thing that's added. We'll say b minus a is 3. That means b is 5. We got our integral from 2 to 5. Okay, this little expression with k, this is a plus b minus a times k over n, so this gets replaced with an x. That just becomes ln x, and then put the dx. Oops, sorry. Okay, and then, okay, so now we're doing source the area into the graph as a limit using some, okay, so we're doing kind of the first thing we're doing on the first page. Okay, so we'll get our delta x for these types, or sorry, our xk first. So that's a plus, but you know, here we have a and b. A is 0, so 0 plus, and then we don't need that. And then b minus a is 4. It's 4k over m. Okay, our delta x is b minus a over n, so just 4 over m. Okay, so that means our integral is from 0 to 4, this function. Okay, and then basically we'll just rewrite this function, but instead of that x, we'll write 4k over n, and then put the b minus a over n on the outside, maybe in parentheses, both those. Okay. This one, our xk is a plus b minus a times k over n. Okay, delta x is b minus a over n, no k. So our integral is from 1 to 6. This will be really 3 over. Place that x in the denominator by delta x, or xk. And then that gets times by b minus a over n on the outside. Okay, a is 0, so that's 0 plus. B minus a is pi. That's pi k over n. Delta x is just pi over n. Okay, so our integral will go from 0 to pi to sine x dx. Okay, so it'll be 2 sine, instead of x, we'll write xk. And then put the b minus a over n on the outside. Okay, our xk, a is 0, so 0 plus. B minus a is 4 times k over n. Delta x is just b minus a over n. Okay, so we got our integral from 0 to 4. So it'll be 3 times square root, instead of x, write 4k over n. And then times that by b minus a over n on the outside. Okay, so super repetitive, you can see. The only thing, yeah, the only thing I'll say, let's say you're doing something like this. You know, there's so many different ways to write this, or not so many, but there's different ways to write this. Remember, you could write this in different ways. So you could shift the function, let's say to the left or right. So for example, let's say you wanted to do like a transformation, like shift this lnx function. Let's say you want to shift it to the right one. So this would be ln of x minus 1. So that shifts it to the right one. So if you minus 1 from the x, you have to add 1 to the limits. And this would be the exact same thing. You could type both of these into the calculator and you'd see you get the exact same answer. You could also do another way. You could ln of x plus 2. So you're shifting it left 2. Okay, and then you'll just go from 0 to 3. Right? So this got added 2 to get x plus 2. So these get subtracted by 2 to become the new limits. So any of those could be the answer. You know, and I was kind of doing that one just in case you get, you're looking at a multiple choice, and when you do this right away, that might not be one of the answer choices. You might have to do one of these transformations. So, okay, but that's the gist. You can see kind of super repetitive once you do them a bunch.